Someone else designed and built this robot, took it off their hands, all of the electrical, the C code, the inverse kinematics, all the motion profiles, the velocity profiles. Me and my partner had to design from scratch, like nothing to start with.
Also, we designed like all the workstation and like the bins, the end effector.
So this was a first prototype we had of the black one. So he designed it so we could slide it in here. We can put 4 kilograms in here and it won't permanently deform.
Does 6 degrees of freedom still use G code?
We wrote a custom interpreter on our microcontroller. We changed the frequency at which we pulse a pin to control speed, and then we time how long we're running at that frequency to get displacement. The whole thing was designed to have a max speed of 15 RPMs and a maximum acceleration for each joint of pi rads per second squared, or about 1,800 revolutions per second squared. I designed my own 4th order polynomial to describe the displacement. And then from there it goes down, and the whole system has been designed to optimize jerk for our system. And I think that took me a weekend to design. My part was doing all of the simulation software, the C communication. All of this code had to be written entirely by me in a year.
Wow. What was the hardest part?
I would say the hardest part was taking all of the individual parts and then getting them to communicate together. It's really easy to make one file, maybe 2, but to get 17 Python files and 4 threads to all communicate together to then give us the full simulation, that was one of the hardest part. We got just before the point where I could say, robot, go here at this orientation. Change your orientation to this, following a velocity profile. We got just the moment before that and the robot broke. Right now, the shelf that's going to be holding all of the parts that's on this truck right now, the rest of the project we're going to be moving manually down because it's way too delicate to go in the truck. Okay, what do we want to move first? I think we should move this electrical thing first. If we could steal a 3rd hand to get 2 on that end and 1 person carrying that box, and then we can walk this down.
You hold it, you hold it.
I don't know, are the rumors true?
Rumors true about what?
Is there going to be sausage, meat, and bread on a cooked platter for us after the expo?
Usually there is.
Usually? Well, now you've got me. Now I'm worried.
So we have to put it on the ground?
For the time being, yeah.
10? Okay. All right.
So this is gonna take the utmost focus moving this thing because it's a tiny little dolly and there's lots of bumps. I'll take the backwards lead, so I'll walk backwards the whole way.
Do you have any, what is it called? Like a rubber band or anything?
We could possibly use some wire.
Zip tie?
I think we have some zip ties. I'm gonna try and get over to the left.
To the left?
And come, yeah, right about there. No, we're not, we're cockeyed here. Okay, you ready? And we're moving. Strong.
The arm is just pushing this down.
Yeah, so you're gonna have to hold it there.
Yeah, I'm holding it there.
Can you press the... Try and line yourself up with me. Because we're going sideways.
I can't.
You just walk a little bit to the left. Oh, hold on. We slipped off a little bit. Push it back your way a bit more.
My way?
Yeah, we just slipped off a little. There we go. Push it your way more, and then I can just stand on the side here because it's killing my back.
Yeah. Just don't push down this forward. You have to hold this
I got
part.
it. Okay, ready? Okay. The tools that you need should be in here.
No.
Oh, sorry. So right now Ashkan is attaching the robot's pedestal and its resting mount to the shelving, so it's one unit. Makes it much more solid. And then once he's done that, I'm gonna get all of the electronics set up and get the software running on it. So what's it now? About a week ago, this joint right here broke on us just due to a poor mechanical design. So we got it fixed like last night and we haven't been able to test it. We won't be able to test it until like today.
Oh, I think we should switch position.
Oh. No! We have the spare.
All right, go.
No, crap. I just, in my haste, was moving and my knee just clipped the end of this and snapped it up. But we do have a spare. An older model, but it is... I'm gonna stop touching stuff. I'm gonna go run and go print a new gripper, but we do have a spare. Ashkan, so while I'm gone, slide the electronics down how we had it before, but I'll let you worry about the layout, okay? Okay.
Oh, so I'm wiring up the motors on the robots to the motor drivers here. So once we start the system, we plug it in, everything will be powered up and we can start moving around the robot. So each motor is drive with one of these motor drivers here. They get some signals from the robot's microcontroller. This little guy here, that's a TNC 4.1. It gets all the data from the computer, process it, send the process data to the motor drivers, and the motor drivers send the signals to the motors for like controlling them. One here, one here, one here, one in the middle, it's inside, one there, and then another one for controlling the end effector.
I tried 5 different times with different slicers. It would not make it past the halfway through the first layer. The whole thing would fail. I tried my damnedest to get it to work, and it wouldn't make it past the first layer. I gotta do all the software and get the robot moving.
Give me your STL. I will sort it out.
Okay, I'll set it to you. Do you have a flash drive on you, or I can just...
No, because all my stuff's back in 115.
Okay, I'll email it to you here. This just came out. So this is the safety control panel. So this has a motor e-stop and a system ignition. So this will allow me, while I'm controlling the robot from here, to immediately have access to all the safety features. When we want it to do with automatic motion and working on it fully independently, we'll switch into that. When we want to take manual control of the robot, we switch into manual. This will start the sequence, stop the sequence. These don't have a function at the moment. We never got around to implementing those. But for today, we only have these 2 things enabled. I'm controlling everything on my side. So this just gives me low voltage power. I pull this out, motors are active, I smash it in, robots stop in their place. And then we have a standby emergency stop that we'll have somewhere else to stop it in case any emergency happens. So if I'm here, Ashkan's on that side, he has access to that in case of an emergency. All right, we're doing it right now. I have connection, everything's ready. I'm gonna be taking control of the robot. Do you wanna stand by the e-stop when you're ready? So right now, I'm gonna tell the shoulder lift to go up. From 90, I'm gonna say go up to, let's say, 70, just to get it out of its resting zone. Okay, ready? 3, 2, 1. Wait, hold on. 3, 2, 1. Robot is not in motion. TNC, 1.2 seconds. During motion. Status change. Okay, powered off and unplug it. Checking that this wasn't put in wrong. Ground power, ground power, ground power. We got that, we got that, we got that. Okay, turning the key, removing motor control, connecting to robot. Okay, I have connection. I'm gonna move the very last joint 10 degrees. Okay, the last joint moved. So now that I know that I can move the robot, I'm gonna move the shoulder up a little bit. That motor did not move. I'm looking at the gears and it didn't move at all.
Do it again.
No, that motor is not moving whatsoever. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Ground positive, ground positive, ground positive, ground positive, ground positive. Let me, okay, go for it.
That's it. Does it hold itself?
That's not good. Oh, and it gave way. This whole thing, look at this, look at this, look at this.
That one is moving.
So
the
I
gear
literally
is-
felt just something give way.
It's the gear.
This gear just went.
Yeah, move up. Yeah, the shaft is moving with the gears.
Okay, we need to prop this thing up so we can get the rest of the joints moving. So here's what I'm thinking. Prop it up. We'll get a big 2x4. Prop this up right here, right on there, and we get the other joints moving.
A piece of wood need. Yeah, all the way, up to my second finger. Maybe just
It's
about the same. Yeah, okay.
I think that's good. I think that's good. Energize the robot. The whole project is designed to take these part bins from the shelves, and you just pick which ones you want. I want this one, this one, this one. And I click make order. It will then read from a database that we wrote to know the location, orientation of them, and then it will show you, okay, here's the path it's gonna do. From the 4 parts you picked, here's the entire path, and you would say, yes, confirm that path, it looks good. Then it would actually show a live animation of the robot doing its whole motion execution. It would show that in real time, and then you say, I like it. You would click confirm the simulation. It would then take all of that data that just simulated, transform it into signals to send to the controller, send it over there, and then the robot would then execute it. Pick them up, deliver them to the user. The user would walk away, do what they so please with it. When they come back, it will return it, and the robot will weigh it to determine scale or determine the stock.
Wow,
and then we'll
estimate
put
the
it back.
inventory based off of that.
Yeah.
That's,
And if I go refresh, snap 5.
wow.
And now update itself to.
Weight that has updated.
Yeah. So then we have this set up, so a technician who wants to order more parts could get the current stock and it would email it to whoever and be like, we need more of these nuts and these bolts, go order them. I need 2 kilograms to fill up. I estimate that's gonna cost $40 or whatever.